All right, we just got done calculating our first, second, and third quartile, and then also finished calculating the minimum, maximum values of this home selling price here. Now, what does this tell us? Well, what this tells us is that if I was going to divide my data set into observations into 4 quadrants, so imagine if this was on a continuous line, and I would start with the minimum value, and I would end with the maximum value. And if I were to divide it up into quadrants, I can use these numbers here to figure out which observations go into each of these quadrants. Let me show you what I'm talking about. It'll make more sense this way. So I'm starting with my minimum value. And I want to, I just thought of this. Let's go ahead and resort this so I kind of have some way of observing how this works. Let me just do it this way, paste values. So really, what I have is my minimum value should be first. And then I want to look at the number of observations that are between the minimum and the first quartile. That is going to be one quadrant or one quartile. And then I'm going to look between the first quartile and the second. That'll be another group of data points, second and third, and then, of course, to the third to the max. Okay. So this is just nothing more than a resort of this data that's over here. Okay. So let's kind of take a look at this, and let's kind of see what this looks like. So if I want to look specifically for values that are between 108,000 and 139,000, this will be my Q1 values, right? And if I look over here, this is my data set. It's real easy to see. This is my Q1 values. Okay. Now I do the same thing. I'm going to look between these two numbers. These will be my Q2 values. If I look, 139 starts here, and then up to 203 ends here. So these are my Q2 values. All right, and you can kind of see the process, 203,000 to 256. So here we go, 256 right here. These are my Q3 values. And then, of course, the last quartile is here, 256 to the maximum, which are then these. And if you look at this, each one of these is conveniently 3 observations. And that's what it should be, is that this should be based on, a quartile should be based on the number of observations. Okay, number of OBS, that's what that's supposed to be, number of observations. So that's what this information gives us, and it helps describe our data set a little bit more. So we have quartiles, and then we have percentiles. And remember, percentiles is based on the percentage score, and quartiles is based on the number of observations within a certain percentage of the total. Now, all of you have probably seen at one point in time a normal distribution. And I've been drawing this over and over and over again. There's some couple rules. We call it the empirical rule, right? Assuming that a distribution is completely symmetric, that means that the center would be the average. And if we go out one standard deviation this way, and then go out one standard deviation this way, and then we were going to take a look at all of the values that are between these two standard deviations, all right, as plus or minus 1 standard deviation. This will give us approximately 68% of our data. All right. So now, using that same logic, here's our mean. If we go out 1, 2 standard deviations, 1, 2 standard deviations to the left. That's plus or minus 2 standard deviations. This would be 95% of our data. So a lot of times people will say, how many standard deviations did you go out? I went out 2 standard deviations. So that allows me to capture 95% of our data. And of course, 3 standard deviations is almost everything. So if you go out the center, 1, 2, 3 standard deviations to the right, and then do to the left, so they call that plus or minus 3. Supposedly you get almost all the data. It's like 99.997% of the data. All right, this is the basic empirical rule, and this is for symmetric bell-shaped distributions. Right, this is important because this is kind of how statistics is valued. So when we look at data sets and we get all these measured values that we've been talking about, we make an assumption that it's normally distributed. If it's normally distributed, then we can say, well, if I look at 95% of the cases, or if I look at plus or minus 2 standard deviations, I will be evaluating 95% of the cases. So then I can, with a degree of confidence, evaluate a set of data with a certain degree of confidence, or 95% degree of confidence. So if you happen to be outside that data set, so coming back over here, if there was a data point that exists out here, far to the left or far to the right, a lot of times they'll consider those to be outliers. And they may be anomalies that are abnormal data points that may not necessarily have met all the same conditions that all the other data points were collected under. So keep in mind, when you're making observations, you're assuming that things are remaining constant. Like, for example, with SAT scores, you're assuming people had relatively the same education. They're 17 to 18 years old, and so on and so forth. Every now and again, you get someone who doesn't have the same level of education. They might be younger, they might be older, and of course you get some variations, and that's what causes some of these outliers. So it's important to evaluate outliers, right? And that these are data that is minus 3 or plus 3 outside that z-score, or I was using standard deviations earlier. Okay. One of the valuable tools, if you don't want to look at a complete distribution, is also a box plot. And a box plot basically is the min value to the first quartile, to the median, to the third quartile, to the max. And it just basically says that this is the distribution of observations across those particular ranges. And if you look at this figure here, this is the home data sales that we had. So that would be that min, that would be the first, second, third, and then that would be the maximum value. Okay, let's take a look at, see if we can create this box plot here. And that's just another example box plot. So let's just go back to our Excel sheet. And box plots are real simple. You select the data, go to Insert, right here. This is available in 2016 and 2019, looking at box plots. Right. So select their data, go to box plots. And here we already have our box plot put together. Now, I don't always like the way that Excel just goes ahead and throws in a box plot, but it gives us some information. Let me make this a little bit bigger. I'm going to change the layout. I'm going to put some numbers to it so we can kind of see how all these numbers go together. And I want to point out a few things, okay? The first of all that we can see, we've got something interesting, is that 219 was our average. But let's take a look at these numbers right here. Right? All of these numbers match up to these numbers out here to the right. We have our minimum, first quartile, second quartile, third quartile, and fourth maximum. And one of the most important things here is we have an odd ball. That is an outlier. Okay. So those are quick, easy ways of looking at distributions. I hope this helps. Good luck.